Hey everyone, welcome to the NVIDIA YouTube channel. I'm a radiologist and software developer. Today I want to show you something that completely mind-blowing, which is NVIDIA MAISI, an AI tool that can generate completely synthetic CT images that look absolutely real. As a radiologist, I was skeptical at first, but after testing this tool myself, I had to share it with you. This could make better how we train medical imaging models. What is NVIDIA MAISI? It stands for Medical AI for Synthetic Imaging. It combines three sophisticated AI networks to create synthetic CT images that are virtually indistinguishable from real scans. First, there's a volume compression network. It was trained on thousands of CT scans, MRI scans. It compresses 3D medical images into a space called latent space while capturing all essential medical information. Second, latent diffusion model. This diffusion model learned from, again, thousands of CT volumes covering different body regions and different disease conditions. The third one is control net, provides fine-grained control, and you can input your segmentation mask showing exactly where you want organs or tumors. MAISI generate these images. Why this tool is great for radiologists or who is interested in AI in radiology? Because it can generate 3D CT scans up to 512 and 768 pixels 3D images. It has variable voxel size from 0.5 to 3 millimeters, and you can annotate up to 127 anatomical structures. And I think this is the most important one. These CT scans belongs to nobody. These are not real patients. You don't have to worry about privacy. Let's talk about hardware requirements. Officially, it requires a GPU with at least 60 gigabytes of memory for generating high resolution image. I tried it with a 24 gigabyte memory, which is NVIDIA RTX A5000 GPU. You cannot get full resolution, but I believe you can test it. Now let's test it. Easiest way to try MAISI is through NVIDIA's online platform, which is build.nvidia.com. And let me show how you work it. You open NVIDIA website and select body regions you want to see, and select anatomical locations, select dimensions, and then tap run, and you can see that it automatically creates a CT scan. This is coronal section, this is sagittal section, this is axial section, and when you click load segmentation labels, it shows anatomical landmarks. You can see here. It's fascinating. Now let me show you how I actually run this on my RTX A5000 with Docker container. All we need is NGC API key from NVIDIA, Docker container, which is also supplied by NVIDIA, and NVIDIA GPU. Now you can follow the documentation. I already completed all of them. Now I just wanted to show you. Keep in mind that it downloads something after the initialization, so it can take 10 to 12 minutes to be fully functional. Here, after creating container and completing build, you will see a screen like this, and you can check running, or you can check it's ready. Yeah, you can see that both Triton server and MAISI model are ready. Means that we can start creating CT scans. Here are some example codes. I used them and I created an example pipeline for this. Let's test it. It can take 2 or 3 minutes to complete fully. After generating image, it creates as file in the same directory. It's created, as you can see here, and it's working. Now I'm going to download it to my computer and show you. I'm going to test it with 3D slicer. Let's select them and load into a 3D slicer. This is labeled, so I'm going to Pick the segmentation. Yes, as you can see, it created. You can see here annotations. Yeah, it's 3D. Yeah. These are the format images. Yeah, as you can see, it created. Can visualize generated scans using 3D slicer. You may think that this resolution is too bad, but when we want to train a model, we always downsize the scans because they don't fit into the GPU memory. I think you shouldn't worry about that. Yeah, that's all for today. We created a synthetic CT scans using NVIDIA MAISI and our own GPU. I showed how can you use it online and how can you use it on your own GPU workstation today. If you have any questions, don't hesitate to ask by email or comment. See you.